Alright, good morning students. Today I'm going to go through one question with you that uses the principle of moments. So this is a simple typical question involving the principle of moments. The diagram below shows a simple seesaw setup with two different weights placed at the ends. Find the distance d, neglecting the weight of the seesaw. So I'm just going to show you 5 simple steps that you should always apply when solving these kind of questions. Alright, step 1, identify the pivot on the diagram. So firstly, looking at this diagram here, which one is the pivot? As you can see here, this will be your pivot. So before you start solving the question, it is always very important to know where is the pivot. Alright, let's move on. Step 2, identify the forces and directions in the diagram. You must identify the forces and the direction. So what are the forces in the diagram? So we have two forces, 30 Newton and 10 Newton. So we have two forces, so I will just write it down in the space below. Next, we must identify the direction of the forces. So for the 10 Newton, what is the direction of the forces? As you can see here, if you follow from the pivot and the direction of the force, the direction of the 10 Newton is anti-clockwise. On the other hand, the direction for the 30 Newton is clockwise. So once we have finished step 2, we will move on to step 3, where we need to identify the perpendicular distance on the diagram. So from the diagram here, which one are the perpendicular distance for the two forces? Let's start off with the 10 Newton. So firstly, as you can see, the 6 meter forms a right angle with the 10 Newton force. You must always remember, when measuring the perpendicular distance, it must always be from the pivot to the applied force, and it must form the right angle. So in this case, for the 10 Newton, the perpendicular distance is 6 meter. So right now, what do you think is the perpendicular distance for the 30 Newton? I hope you got the right one, because the distance is d. Alright, so we have done the first 3 steps. Step number 4, calculate the moments. Now, moment is given by the formula F times d, the force times the perpendicular distance to the force. So to calculate the moment, so for the first one, the anti-clockwise moment, the calculation would be 10 Newton times 6 meter, giving you 60 Newton meter. So can you calculate the clockwise moment? So to calculate the clockwise moment, using the same formula, it will be using 30 Newton times d meter, giving you 30 d Newton meter. Lastly, applying the principle of moments, we know that for an object to be balanced, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Hence, we know the anti-clockwise moments must be equal to the clockwise moments. So using the concept here, we can equate them together. 60 Newton meter will be equals to 30 d Newton meter. So in order to solve for d, you will just take 60 over 30 will be your d, and hence your d will be 2 meters.